So in this example, we are going to take a look at how we can determine the end behavior of a polynomial. And let's just summarize a couple of key points that are going to help us identify that behavior. And so if I have a polynomial, and let's say its leading term is a n times x to the n, then its leading term is going to determine the end behavior. And so when we talk about the end behavior, what we're looking at is what happens to values of the function f of x as x goes to positive infinity, so as we go all the way out to the right, and what happens as x goes to negative infinity, as we go all the way out to the left. And so these values are going to be determined by this term here, since when x gets really large in a positive or negative sense, this is the term that's going to overpower all of the others. And so a couple of observations that we're going to need to keep in mind. The first is if the leading coefficient a(n) is greater than 0, then the function f of x is going to go to positive infinity as x goes to positive infinity, okay? And this is because if a(n) is positive, then no matter what n is, a positive number raised to the nth power is going to be positive. So this whole term is going to be positive. So if the leading coefficient is positive, then the function is going to go off to positive infinity as x goes to positive infinity. And contrary to that, the converse of that is if the leading coefficient is negative, then the function f of x is going to go to negative infinity as x goes to positive infinity, as x goes to infinity, for the same sort of logic. That being, if this is negative, no matter what, this term is going to be positive as x goes to positive infinity. So we would have positive times negative, which has to give me a negative value. So there's one thing. Looking at the leading coefficient is going to help us determine the behavior to some extent. And the rest of the picture we can fill in by looking at the degree. So if n, the degree, is even, then we're going to have the same behavior at both ends. Either both ends are going to go up to positive infinity or down to negative infinity. And on the other hand, if n is odd, if the degree is odd, then we have opposite behavior at both ends. So if one goes up, then the other goes down. And this is going to be enough to help us identify the end behavior completely. So let's take a look at an example. So as we just discussed, to identify the end behavior, the key here is to identify the leading term. So in part A, we have f of x is equal to 7x minus 8x to the fourth. And so here the leading term, right, that's the term with the highest power. And so what we see is, first of all, the leading coefficient is negative. So this tells us right away, as x goes to infinity, f of x is going to go to minus infinity. And secondly, we see that the degree, which is 4, is even. So that means what happens on the other end as x goes to negative infinity, f of x is going to behave the same at the other end. It's going to go to negative infinity. So here we've got a full picture of the end behavior of this polynomial. Namely, roughly speaking, we see that as x goes to positive infinity, as we go to the right, the function goes down, and as we go to the left, as x goes to negative infinity, the function goes down. And we have some behavior in between those ends that we need to do some further analysis to determine. In part B, we now have the function f of z is equal to 2z cubed minus 5z squared plus 8z minus 10. And here, again, we just need to take a look at the leading term, and in particular, the leading coefficient and the degree. So the leading coefficient here, which is 2, is positive. And so if the leading coefficient is positive, this tells me as z goes to infinity, f of z is going to go to infinity. So there's 1/2 of the end behavior. And secondly, we see that since the degree is odd, the degree is 3, that at the other end, we're going to have the opposite behavior. So as z goes to minus infinity on the left, f of z is going to go to minus infinity. And so the rough sketch of the end behavior here, we see that as we go to the right, the function goes up. And as we go off to the left, the function goes in the opposite direction. It goes down.